So like I said in the last video, I wanted to show you really quickly how those Kawaii physics things work. It's probably not going to be a long video since it's actually pretty simple. Though no one really covered it. I don't really get why, because it's like super simple, super good. Like, I don't get it. Either way, we're going to take a look at it. Alright, first of all, you have to download the add-on. Of course, you can see it's like 18 megabytes for Unreal 5 and like 15 for Unreal 4.26. Link will be in the description, and I'm also going to link you to the documentation because it's kind of hidden. It took me a while to figure it out where it is, so I'm just going to directly link you, and it will even tell you what each parameter actually does. Yeah, so this was relatively helpful for me as well. Next, you will have to find where you actually install your Unreal Engine. So 4.26 I'm using here, not Unreal 5 currently. A little bit too unstable for me, but I'm going to make videos about this as well soon. Though for now, 4.26. Once you're in the folder, you just go to Engine, and there it says Plugins, and here you copy in the unzipped Kawaii physics file. So when you download it, you'll get a zip, you right click it, you say, of course I have it in German here, but it says unzip somewhere, and then you unzip it, and the unzipped version goes into this folder. In your Unreal folder, Engine Plugins, you just simply copy it and that's it. Now you can open Unreal and you go to Edit, Plugins, and you're going to look for Kawaii Physics, and there you enable it. That's it. Now it's going to work. So how do we even use this? Now, you will go to your character. I'm not going to explain how to set up a character here. That's just not what this is, but I'm going to go to my Miruko here, and as you should know, each character has a skeletal mesh, a blueprint which stores the logic, and you also have an animation blueprint which we're going to open up. You can see I already set stuff up here, and I'm not going to set up everything again, but I'm going to show you how you can use this. So first of all, I'm going to unplug this here because we're going to do it again. All right, you're probably starting something like this here. You have your default state machine where your stuff is in, your base animations, all right? First of all, we want to make a Kawaii physics node. Right click, Kawaii physics. And here we go, we get our node. And we plug this in, that easy. If we now select this node and we go to the top right, details panel, we have to choose a root bone. Now, we don't want the actual root of our skeleton mesh, we want the root of the physics we're going to do. Let's just do one of the hairs here. So I'm going in here and I type in hair or whatever you call it. So mine are the name convention cc underscore hair underscore tail underscore 01, etc. So I'm going to select one. Let's compile this, and you can see it already works. Now here you have a lot of debug options, so this is essentially just showing you what is going on. If I turn all of this off, I'm not going to see anything. So we actually want to keep this on. Target frame rate 60, this is just fine. And here under the physics settings, we have a lot of settings, a damping curve, etc. We're going to skip this for a second, and we go down here to where it says external force, gravity. Because first of all, we need gravity on the hair, or it's not going to look properly. Now the default gravity you want to start with is probably something like -1000, I think it was. Let's compile this. And you're going to see it's falling down. Now obviously it's very jiggly and whatever, don't worry about it. And you can see it's also falling through the head here. Now, since I started my bones so much up, I kind of want them to start a little bit later, right? So I'm just going to move the root bone further down. So instead of the 01, I'm going to use like the 03, and let's compile this. And a little bit later, which is looking a bit better. Of course, we could do this with like collisions, but it's just unnecessary, you know, it's just a little bit cleaner. So the next thing I wanted to do is go to the physics settings here, and here you have a little button which says bind. Instead of bind, you're going to click expose as pin, and you're going to see we have now another pin here. Let's drag this out, and if you have context sensitive on, there's only one thing you can really use: make Kawaii physics settings. And if we unfold this here, these are the same options as you have or had in here. They're gone now. The reason we're doing this is because we can now copy a lot of nodes and can just use the same settings, which is super handy. And it's a little bit cleaner here. Now we should take a look at the documentation. Damping physical behavior. As the value is smaller, the acceleration is more reflected to the physical behavior. So what this means is, with less damping, it's going to react quicker on acceleration changes, I guess. So let's just take a look here. Yeah, pretty aggressive. So maybe you want a little bit less. Let's use a little bit more because otherwise it's stronger. So this is like a 0.25 maybe. Let's hit compile. Let's take a look. It's also always depending on how long your hair is. This is a bit more calm. Well, damping location. So degrees of influence from movement in the world coordinate system of the skeletal mesh component. So if we turn this off here, hope 0 is off, and we're going to run. It's going to be super strong, yeah, because the world, the difference the character has in position to the world from before is going to be super strong. If we change this to a 1 and hit compile, now move around, you can see the hair is still falling around with the character and whatever, but the world difference the character is moving in is like super low. So let's just see how much we want to actually affect it. Maybe a 0.8 was pretty okay. Let's just see. Yeah, I guess maybe a little bit less. So less would be a bit higher, 0.85. What is next? The world damping rotation. Degree of influence from rotation in world coordinate system of the skeleton component. So this essentially means when we are like rotating around. If we make this super strong, I guess that's a 0. Yeah, you can see like it's super quickly rotating. So it's essentially transferring the rotation. I guess like a 0.8 might also just be fine. Let's just take a look at that. Yeah, that's just fine, right? This is not too aggressive, but it does something. Stiffness. Stiffness of physical behavior. As the value is larger, pre-physics shape is more respected. So the default position the character has with the hair, yeah, how you rigged it, how the default pose is looking, will be more respected as this value gets higher. Let's just put a 1 in here. You can see it's essentially not moving because it's fully respecting how I rigged it, how the default position is. And as we get lower, it will create its own movement essentially. So it's like a blending value. It's super tiny now. 0, I guess it's not going to respect it at all anymore. Yeah, it's just not finding the default position at all anymore, or barely. So we probably want like a little bit of a value here, because we want to find back to this original position. 0.015 I think was the default. Let's just take a look at that. I think it can have more. It should find its default position. So like let's try a 0.2. I want to see. Yeah, as it's stronger, it's more like a wiggly thing, like for the breast or the ears, you know. So we want actually something very low here. 0.02. Let's see. Yeah, it's still falling, but it's going to find back to its default position. So what is the radius? Radius of the bone collision. Okay, we can skip this for a second. Limit angle. Rotational limits in the physical behavior. Setting the value properly can prevent rampage here. So essentially we have 0 now. The hair can go in all directions. I'm just going to put in like a 15 here for now, so we only have like a 15 in rotation here. You can see the hair is not going to go further back than 15 degrees. And if I make this 0, it can completely freely rotate. So depending on how long your hair is, of course I want my hair to eventually even fall up and whatever, so I'm going to keep this at 0. But if your hair is like relatively short, you might want to limit this to some extent. Or for example, for the ears, I think I did this because I don't want the ears to like bend over. All right, this is essentially all the settings. You just gotta like get through this and get used to it, I guess, and play a bit around with that. Now, before we cover the collisions, I want to cover another thing as well. We have the curves here, which correspond to those settings here. Let's just make one example here. Let's use the radius curve. I think this is something we can actually visually see. So we can plug in another group here, another curve here. You can see I have a lot of curves here. We are going to make a new one. So I'm just going to put this in here, right click, miscellaneous, I think it was, curve. And we want a curve float. We only need a single value. We don't need multiple values. So we just make a float here. Call this YouTube or something. And we can open this up. Now, what you want to start with those curves is right click. You can create a key. Right click, create a key. We at least need 2. So select one. And up here you have the values. So you want to start with a 0 and a 0. And the other one should be 1 and a 1. This is the default value. I would at least start with. And you can go over here to this sign and just click on absolute view and you will have it like properly zoomed in. What this curve does, it multiplies along the bone, meaning this part here is the beginning of this whole chain. This part here is the end of the chain. And it will take this value, the current value of 3. If I make this radius bigger, you're going to see that the collisions got bigger. So it will take this 5 and in the beginning multiply it with a 0, which is 0. So if I'm going to plug this curve in, this top one will disappear and to the end it will be 5. Why? Because the end is 1. So 5 multiplied with 1 is 5. You can obviously also make it smaller in the end if you would like give it a lower value, right? You could probably invert it or something, which makes no sense, but you could do this. You could also go higher over 1, so it's getting even bigger, like 5 times 2, right? So how do we get this in? You would just need to select it here, right? So like compile, and you're going to see, like I said, in the beginning it disappeared, in the end it's 5. But I don't recommend you doing this. Let's just skip it out here again. I would recommend you just click on this here, expose this bin. And then you're going to right click on here and promote to variable. So it's already creating the right thing for you. You need to hit compile so you can actually select a curve. And we have this in here. If I now hit compile, we got the same result. Now the reason I'm doing this is because you will have a lot of nodes for a lot of hair. And this way, if you're just like exposing it and promoting it to a variable, you can not just reuse the same curve if you have something that works similar. You can also like plug it into multiple. So let's just copy this over, plug this in here, make a reroute node, double click, let's down, make a reroute node here, double click, drag this up, down, and we're going to plug this in here as well. And the only thing we have to do is change the hair. So cc underscore hair underscore tail and 0 to row. So let's compile. And you're going to see I have the other thing here as well. Now it's falling in. I don't quite want to 0 to. I kind of want to decrease the collision here in the beginning. This is something I do because it's like a little bit more accurate, I think. Though it's a little bit too extreme. Now I can use this curve to modify this. I don't want a 0 in the beginning because this would mean I literally have no collision. I want to start with like a 0.2. And I'm going to save this. Actually, is it updating in real time? Let's just drag this a bit higher. Actually updating in real time. Very nice. We can see this. As higher the value is, as stronger the beginning will change. Seems about fine, I say. Now you can do this with all of the curves. So you can essentially say that the beginning of the hair has more dampening than the end. And you would get closer to real looking hair. You can also make it so it's like accelerating. This word dampening was the acceleration. I think it was. Let's just take a quick look here again. What was the acceleration? Acceleration is actually the first one. So you kind of want the low one to accelerate a little bit faster, I guess, or maybe not. You want the upper ones to accelerate faster than low ones, then directly to the head. So the low ones would accelerate slower. And stiffness, obviously, the upper ones would be stiffer than the lower ones because they're also to the head. You can limit the angle of the top ones more than the lower ones. So those here don't bend as much, maybe like 10 degrees or something, and down here full. Now, a quick side note here. I set up my skeleton mesh. Let's take a look at the skeleton mesh. I set it up in a way so I have an extra bone in the end. So I have actually a location right here. If you rig your stuff in Blender or whatever, you might not have this because you don't think about it, that you need to create an extra bone here. If you don't have this extra bone, you can just go down here where it says dummy bone, and you can just, I guess, put in a 1. And X positive, you gotta figure out which axis your bones look at. You can easily do this. Mine, for example, look -y. Why? Because y is looking up. And I want the one that is looking down, so the opposite of this one here is -y. And I would need to check negative y negative here. All right, this is what you have to do if you don't have a location at the last part of your hair. Though I rigged my stuff keeping this in mind. I knew that I had to get an extra bone there, so I don't need this option. So let's go to the collisions finding. Here we have this spherical limits. Let's just create one and unfold this here. First of all, we want to set up a driving bone. In my case, it's obviously the head. So let's create a head, put in the head here, and let's compile. And we're going to see we have a collision here. Now, I think we could select this, but I gotta warn you, sometimes it crashed on me when I did this. And there's a different way, just follow along for now. We can offset the location, obviously. I would also pause this maybe. It's probably a little bit more stable. And then drag it maybe around. and scale it up. So something like this here. Now, obviously you can work a lot more accurate than me here right now. I already did this. And with that, we should be good to go. Let's hit play here. Let's compile. And if I make a run, it's going to collide right there. Then you have the rotation offset, which really doesn't matter for a sphere. It doesn't matter which direction the sphere looks. Let's take a quick look at the capsule collisions here, which you could use for the arms. For example, let's use, I don't know, arm, upper arm L, pile here. And you can see it's right here. So let's just rotate it here 90 degrees or something, move it a bit down, and we can probably also scale it around Z. There we go. I'm just doing this roughly right now. And we would have a collision for the arm as well. Pretty easy. Now what we can do is we can, because we know we need it on the other side as well, right? So we can just unfold this here and we can duplicate it. So we just have to change this from upper arm L to upper arm R, and we would compile it, have it on the other side with kind of the right things here. We just gotta like drag it in, right? And voila, we got this. The problem though is we are doing this right now only in one node. And I doubt you want to set all the collisions up for all the hair in each node. So we're going to do this a bit differently. I'm going to delete this here again. Trash bin here. All right, compile. The way we want to do this is using a data asset. You can see I have data assets in here. We right click here under miscellaneous. There is this, miscellaneous. There is this data asset here, which we want to create. And then we want to take a look for Kawaii physics. Here, limit data asset, right? Select it. And I don't know, Ue4 or something, whatever you want to call it. We're going to open this up. Let's make it in another window here. And we can scroll down, and here we can just Ue4, put it in, hit compile. Though we still don't have any collisions here right now. And you can see those options we have in here are the same ones as we have in here. So instead of using those options, we're going to use those options. For example, spherical limit, unfold. Here, driving bone name. Here you have to type in the proper bone name. So I recommend you to also open up your skeleton asset. So you can just find whatever bone name you need. Here it's exactly called head. You could right click it, copy selected bone names if you wanted to. Go back and paste it in. Yeah. And you can see it's directly at the head. It's updating in real time, which is kind of nice. So we can make this a bit bigger. We can still select it, but this version, or sometimes selected, but this version sometimes crashed on me. Okay, so be careful with that. We didn't put it into the first node. Let's also put it in the first node here, Miracle. And you can see now both nodes use the same collisions. All right, we got a collision here. Can make another one, and I'm going to kind of parent this. I don't know, copy this here, copy select bone name. Paste it in, all good. Let's go back here, select it, maybe F, zoom a bit in, make it a bit bigger, move it a bit along X. So, and we got this in here as well. Now let's compile, you can save or something, and you can see it's going to collide right here. Now you can see the collisions here are actually way too big. Yeah, they might actually be able to get way smaller. This is due to our curve. We can just now grab our curve here and drag it down. We want this very slim in the end to be more accurate. And this is essentially it. If we take a look at the one I did originally, let's just put this down here really quick just to show you. Yeah, you can see I set up the collisions in this data asset for the whole body, and I plugged it into every single hair node. And then additionally, I also did the ears. You can see the ears, which don't even have collisions because they don't need to. They just wiggle around. For the breast, I did something as well. You could use the Kawaii physics thing as well. I used spring controllers, which is in there by default for Unreal, and you just gotta like set up the one you want to let spring, and you just have a bunch of options here, but this is not related to the Kawaii physics. And yeah, that's essentially it. Let's do a quick recap here. You download the folder, unzip it, put it into the plugins folder of your engine. You open up your blueprint, your animation blueprint, and then you find your Kawaii physics nodes, in which you're going to set the root bone, so the first bone along the hair, which is closest to the head essentially. You keep this stuff on so you can actually see. You only see when you like select a node and it's actually plugged in. You go down, find your gravity, set it to -1000, which is roughly about right, and say you go up to the physics settings, you expose the pin of the physics settings, you're getting yourself the Kawaii physics settings node, and you play through the values using the documentation in the description. You can create curves which multiply the original value you have set here. The first one should be at 0, which is the first bone, and the second one you're just going to set kind of where 1 is, 1 here. So it's the last bone, and then you can change the value to intensify or lower whatever value you want to use here. It's multiplying. So 1 will be exactly this value. Then you create right-click, miscellaneous, where is it? Miscellaneous data asset. And you can open this up. You will get access to the spherical limits, the capsule limits, and the planar limits. And this asset goes down here in limit data experimental and plug it in. This should essentially go into all your nodes because the character has certain collisions everywhere. And you can create multiple nodes. You can just copy them and plug in your Kawaii physics settings as well as the curve. For the curve, you want to right click and promote a variable so you get the right thing. When you did that, you have to compile or you won't be able to set your curve here. Another thing we can take a look at really quickly are the planar limits. They're a little bit different, but essentially they are the same. So let's just use the head as an example here. And we're going to see our plane here. Now, this can be a little counterproductive depending on what you are doing. Because it's limiting the full range. Like it doesn't matter how far it goes over there, it's never going to get around the plane. So you can see it's actually at some point it's clipping through, but it's never going to get around the plane essentially. This is essentially all the planar limits do. And yeah, we're kind of done here. A quick side note, I don't think it's going to work for skirts. I tried to use it for skirts, but the problem with skirts is, I can really quickly show you. If you imagine I have a bone row here, right? And a bone row here. And we have our collisions right here. And the leg moves against those collisions. All right, the thing is moving up, right? But what is if the leg moves through here? There are no collisions. So we would need a way to constrain this here to this here, yeah? So if the bone moves up and it moves against this here, this one follows. And the other way around. So if this one is hit, this one follows. There's a logic error which you cannot really do in Kawaii physics. This is why my skirt is still in the physics asset. Skirts currently we still have to do in this stupid ass physics window. No way around it, I guess. Unless we get like some work in math that fixes this constraint problem. But yeah, that's it. It's actually not very hard. You just gotta like work through it, take the documentation to read the values, set it up like I showed you. It's actually not very hard to get pretty good looking hair. I didn't really spend a lot of time on the hair. I really just quickly did it. And I think it's pretty acceptable, honestly. I think if you put a little bit more work in, you can make this look a little bit nicer. Yeah, I hope this video helps you because I think this add-on is really valuable. Especially if it would get a lot more support. I think it doesn't really get any support whatsoever. Like I said, it's not really covered at all. I think if there would be more attention on this add-on, maybe the developer could also put more time into it and whatever. He already updated it to Unreal 5 as well, so this is amazing, really. Either way, if you like this video, please consider helping me out on Patreon. It would really be appreciated. And I guess I'll see you in the next video. If you have any ideas what I should cover, let it be in the comments. I'm gonna do it.